In this video, I'll explain why we need to manage context in a complex application. I'll then discuss what this has to do with Java naming and directory interface, and contexts and dependency injection. If you've been following along with the videos and tutorials for this subject, you will have already been using context management services of an application server, perhaps without understanding exactly what they mean. I used initial context.doLookup to get access to a JDBC database connection that was configured and pulled by the application server. I used a session scoped annotation on a Java server faces backing bean to tell the application server that it should manage the backing bean on a per user basis, which should survive multiple requests. I also used a name annotation on a Java server faces backing bean. That meant I could refer to it by name in a facelets view. And actually, these are all part of Java EE context management. An application server provides many services and features, and the point of context management is to provide these to your own application. So why do we need it? Well, obviously, we need to get access to those services of the application server. But can you think why we might need some sort of specialized context management? Why can't we just directly create new instances of services using Java's new keyword? Why can't we just create a new database connection? Or create a new connection to an email gateway and so on? Well, there are two problems. One is that the Java EE specifications define interfaces, but every implementation of these technologies that the Java EE specifications define will have a different name and different packages, so you don't actually know what concrete class you actually need to create a new instance of. The other problem is that when we deploy our applications, it may need to be configured differently during development versus testing. In a complex multi-tier system, you might have different configurations on every computer in every tier. So this means we can't just instantiate and configure the services in code. We need to get configuration data from the application server. One solution to this problem is called inversion of control. Traditionally, when you build an application, your code is in charge and it creates and manages all the services that it needs to use. In an application server, using inversion of control, everything's inverted. So the application server is responsible for creating and managing all the services that you need. In fact, the application server is responsible for instantiating all the instances of your own classes as well. Then your application simply makes use of those services that the application server has created. You can see here that with inversion of control, it looks like the application is contained inside the application server. For this reason, you sometimes might hear an application server to be referred to as a container. By using inversion of control, we solve the two problems I just spoke about. We don't have to worry about the specific instantiation methods required by each implementation. We separate configuration information from our code, from our domain logic. Because the services are provided by the application server, they can be managed by the application server, and they can even be reconfigured at runtime without you needing to change the code. And finally, you can make changes to your configuration and to services without needing to recompile or modify your Java code. In Java EE, there are two main approaches. Java Naming and Directory Service, or JNDI, is one, and the other is Contexts and Dependency Injection, or CDI. JNDI uses a request-based service. In your code, you query the container for the service you need. You ask for the service, and the container responds on demand. CDI is the opposite. The container directly provides the application with the configuration it needs. The container detects places in your code and makes use of the services, and then it automatically sets or injects those services as appropriate.